Okay, well, thank you everybody for joining another one of the Siemens webinars. Today we're going to get into some advanced programming content that specifically looks at variable programming. So this is a continuation of a webinar we did in the past, so we will be referencing that, and hopefully you guys will get a lot out of it. I had quite a bit of fun putting all this material together and digging into some of these more advanced topics, shall we say. So I am your presenter. I'll be your guest speaker for today. Let me just see if I can get that out of the way. You know, they change this interface on me all the time. So it seems like every time I come in, things have moved around a little bit. Okay, so I'm going to be your presenter. My name is Chris Pollock. I am the manager of our Virtual Technical Application Center. So that really means that I do a lot of the online and web-based content for Siemens, specifically when it comes to operation and programming topics. So I am certainly a resource here for you guys if you need me for all things Siemens, but especially stuff from the operation and the programming perspective. So there's my contact information. Certainly feel free to reach out if you guys have any questions, concerns, need help, or just want to give me feedback on this program. I always appreciate those kind of calls as well. So we do have a couple events coming up that I'm excited to kind of pitch and promote. Our next webinar in May is going to be specifically on creating post-processors for the SINUMERIK control. You know, I get a lot of guys that reach out to me that either have to work with a CAD/CAM company to develop a post-processor for their machine, or they're the post guys writing it. So what I wanted to do was kind of create a webinar specific to all the things you would need to do to build a post-processor. So not actually building one specific to a given CAD package, but all of the rules and techniques and protocols you need to follow to be able to create that post-processor. So that one is going to be coming up in May, and from there, the next one after that is going to be going into a new tool that we're offering, which is called Analyze My Workpiece and Toolpath. So really cool piece of software. What it actually allows us to do is you can either pull data from your real control or even from Sinutrain, and you can analyze what the surface geometry is going to look like from a part program. And you can figure out where there's going to be anomalies, where there's going to be surface deviations. So it's a pretty cool tool, and it works well when you're dealing with looking at surface qualities, degradation, just trying to figure out why you have these anomalies coming up. So you're going to get to see a live working example of that new tool, which is what we're referring to as Analyze My Workpiece /Toolpath. So that's coming up as well. Now, I always like to reference where you guys can find a lot of this online content. So certainly you can go to our main website, which is the CNC for You website link that you see at the top of the screen. Additionally, you can go directly to our webinars with the webinars link you see below. All these webinars are, as I mentioned, they are recorded and they're there for you for a library, and we'll actually be referencing the one that this program builds off of. Additionally, we also offer in-person training at our TAC in Elk Grove Village, Illinois, so just outside of Chicago. And we have a whole host of courses that are available there for you to take. You can see the courses on CNC for You, so by all means, come in, feel free to take advantage of it. These are complimentary courses. We just look forward to you guys getting a chance to engage with us and learn the product. So you can come in, you can register, you can get a course outline, all kinds of stuff right through this website. Oops, sorry. To kind of look into those courses. So today what we're going to be talking about is specific to the 82840. I like to caveat that because we do have the 808 controls out in the field. There's also a lot of legacy controls out in the field. Now with that being said, a lot of what you're going to see today would actually work in all of these controls. But there could be some things that may not be supported in the 808 or maybe wasn't supported in the older legacy controls. So for sure, if you're working on a current 82840, everything I show you today would work on either of those two systems. However, if you do have one of the other controls, like an 808 or like an older 810 or 802, don't be afraid of trying some of this stuff. A lot of this stuff has been around for a real long time, and it's been supported in our controls for years, if not decades. So we're going to kind of try to give you a nice overview of really exploring how do I apply some of the stuff that we've maybe seen in past webinars. So we're going to take a basic cycle, a basic routine, and we're going to kind of pump it up on some steroids, right? So we're going to take a basic subroutine, and we're going to switch it over, and we're going to create a custom M code driven from that subroutine. Once we've created a custom M code, then we're going to turn it into a cycle. And eventually, when we get to the end of this webinar, you'll actually see how to push data from a part program into an external cycle, and then let it come on back and continue on, and we get into error trapping and logic. So there's a lot of material here. Now, before we go any further, I always like to reference where you can get additional information on these topics. So by all means, you want to use this supportindustry.siemens.com website for kind of all things Siemens and SINUMERIK. But specifically, if you're looking for material on this topic, you want to go to the job planning manual. So if you come to the main portal, just do a quick search for job planning, and you'll get a few different manuals will pop up. But go into the job planning manual, and that's where you can find a whole chapter or section on what we call flexible NC programming. And in the Siemens world, flexible NC programming is what a lot of us think of when we hear about variable-based programming, macro programming. There's a lot of different terms in the industry that all mean the same basic thing. We happen to call it flexible NC programming. So that's the area or the chapter you want to go into, specifically in this manual. Then in conjunction to that, when you get into this higher level programming, you actually start to use a lot of system variables. So there's a lot of variables that are there available for you. We're going to explore some of them a little bit. Well, this is your key manual where you can start to find all those system variables. Because, a lot of those you won't necessarily see in the control because they're kind of hidden in the background, right? They're running in the background. You don't physically see them. So come in, look at the table of contents here. There's a ton of variables for you. Here I'm just referencing a couple real popular ones like frame variables, tool variables, but there's all kinds of stuff that we can start to pull out of the system as you're going to start to see here. Okay, but I did mention that this is a continuation on a previous webinar. So for those of us that maybe haven't seen this webinar, there's probably going to be some topics that will be a little advanced for you. What I would say is go back, check out the webinar. You can find it in the archives section of the webinars page. And under there, just go to milling, search down the list a little ways. You'll see the variable programming. That was the entry into this webinar. So a lot of the detail, I'm not going to have the time certainly to go through all the nuances. It was all done in that webinar. So if you haven't seen it, there's things that, gaps that you think I'm jumping over. It's because they were talked about in that webinar. Check it out by all means. Okay, so in that webinar, one of the things we did was we explored the world of creating a basic cycle, right? And that cycle was really nothing more than a part program that was being called up by another program. So that's a nice, quick, simple way in the Siemens world to kind of create functionality, right? So we wanted to do a basic retract cycle. And I'm choosing retract here because it's one of those things that we all have to do, right? You're running your machine. You need to send the machine to a safe location. Well, how do you do that? Well, you use some type of a retract cycle. So in the previous webinar, we had built a basic routine because we were talking about creating variables and pushing variables into different pieces of the cycle to then get different behavior. So we're going to take that example and then, like I said, we're going to kind of pump it up on steroids. We're going to add a lot more functionality to it. So the first thing we want to do is we're going to take the original retract cycle, and in this system, right, in this example, we're going to drop it into the subprograms folder. Because when you get to some of these more advanced cycles, you do have to comply with the normal subprogram rules. And traditionally, when I first get started and playing around in Siemens, I can call any program from any other program. It's super flexible. But if we want to go to these next steps, where we really want to create like custom M codes and do all that stuff, then you have to start to comply with the subprogram functionality. So when I talk about subprograms, there's a few rules that come into play to create something that's truly what's called a subprogram. And first thing is it's going to have a .spf extension. And with that .spf extension, it has to reside in a couple specific places within our system memory. So if you're used to the SINUMERIK system, you know when you go to the NC memory area, you have a part program folder, subprogram folder, and a workpiece folder. So any true subprograms with a .spf extension must reside either in the subprograms folder or in the workpiece folder under a subfolder. You can never have them put them in the parts program folder because there it has to have a .mpf extension, which would be a main program file. So once you've done that, once you've created a part program and dropped it in that folder, when you write the program, you do have to tell it that the end of program is either an M17 or the RET command, which is a return command. Either of them work. You could interchange them, but you would want to switch if you were using an M30 or an M2 in that original source file. You'd want to switch it to an M17 or an RET command. Now from there, it's important to note that once you've created a file or want to make a file as a true SPF file, then there's no conversational programming being supported. So subprogram files have to be G-code files. So with that being said, if I was building a shop mill program, you can only assign a .mpf extension to that shop mill program. So just keep that in mind. If you start getting into this more advanced programming area, you do have to do everything in G-code. Now, you also want to start to comply with our naming rules when naming a part program file. And a lot of people don't realize we have this rule because it's easily broken and the system won't yell at you about it. But when you start calling files from other files, then it becomes important when you start to name your files. And really what the rule is your first two letters of your program name should never be numbers. So you can start it with an underscore, you can start it with two letters, but your first two characters of your program name should never be numerical values. And the reason being is if you assigned a file name just a numerical value, when you get inside a program and you type a numerical value, how do we know that that's pointing to a file name other than just being a number without anything else on it, right? So just keep that rule in the back of your head. When I'm going to name a file, especially when it's going to be a subprogram, I myself like to use underscores to start, but just make sure you either use an underscore or two letters to start the file name. Other than that, you can add numbers, you can follow all the normal rules when creating program names and file names and whatnot. So from here, once we've dropped that program into the subprograms file, I can still call it up as I normally would have. So you see in this case, we're calling up a subprogram that was underscore safe pause 1. And to call it up in the main program, it's as simple as just either giving it the name of the file. So I called mine the underscore safe position 1. So that's where my first two characters, one was an underscore and one was the letter S, were complying. I don't have numbers there. I can also use the call statement to call it up. So either one will work. I can interchange them synonymously, but that's how I would start to call that given file. Now, when I take that file, I may want to kind of go to the next step, right? So I have a file I've created. I'm going to maybe reference it through a lot of my part programs as the safety retract routine. Well, I may not want it sitting in part program memory, right? Initially, we dropped it in the SPF folder or in the MPF folder when we were doing it prior to it having a .spf extension. Well, the problem with keeping files there is now your operators, your other programmers, your users, maybe you're an OEM or a dealer and you're building something for an end user. Those cycles are right there kind of in their face. And there's just too much of a chance that people can go in and start manipulating the cycle and potentially break the cycle, right? So what if I want to take this cycle and move it to an area of memory where it's a little more secure, a little less visible, somewhere where I can still access it and run it with the same program, but it's kind of out of the normal way. That is where I can start to use what's called our cycles folder, and I can actually put cycles inside of this folder, and it's just a different area in memory. But what happens is I can still call it the same way. It's being treated as if it was sitting in the regular NC memory, but it's not over in NC memory. You don't see it. So that's how we're going to start this whole thing. We're going to first take that cycle, and we're going to drop it over into the cycles folder. And then from there, we're going to start to change its functionality a little bit. So I'm going to transition over to SINUTrain. SINUTrain is our machine control emulator software. So this is basically allows me to do everything that the machine tool can do, but I can do it just in my PC. So if I go over to my program memory by going to my program manager area, and I'm just going to compress some of these folders I had open, you see right now I had pre-created this safe position 1 file, and it's sitting in my subprogram folder. It's there because it has a .spf extension, and if I look at it, it's a basic G-code file. So this is literally the program we ran or we created in the previous webinar. And there, one of the things we were showing was creating local variables, using variables right inside of a G-code command so I could dynamically change the value in the G-code command. We were setting variables. So these are all the things that we first started with. So at this case, or at this time, right, we want to now kind of transition and move it over. We want to put it in a secure area. Now, certainly if I was only worried about securing a file so somebody couldn't access it, you can always go to the properties of a file, and you can change, based on different access rights, what somebody can do with a file. But we're also going to get a lot more capability once we put it into the user folder. So what we're going to do first is we're going to take this file, and I'm going to copy it, and now I'm going to navigate to where the cycles folder exists. So if you hit your menu select key, and you hit the setup key, you're going to see there's a horizontal soft key called system data. And system data is where all of our file structure is and everything's saved. And under NC data, which usually it opens right up for you, but if not, just expand your NC data folder. You're going to find a subfolder called cycles. And then in here, there's 3 folders: user, manufacturer, and standard. So what I always recommend, unless you're the OEM that's building the machine, you want to put all of your cycles in the user folder, right? The user cycles folder. So all I did was copy and paste and drop that file in. Now what I'm going to do in this case is I am going to change the name of the file so I don't collide with that other one. So you want to just be careful when you're doing your naming, naming nomenclature or naming convention, that you don't reuse the same name, because then the system may find the wrong file. You always want to use a unique name. So I'm just renaming it to _safe position 2. Now that the file is sitting there in memory, right, I can look at some of the other folders. And why I put it in the user cycle is because manufacturers, OEMs, will put custom cycles in their manufacturing cycle. Now this is a very basic machine. So this just has this L6 cycle. But with L6s, this is the tool change macro. This is what makes the machine do tool changes. So there's really 3 folders, like I said. Standard cycles is where all of our base Siemens out-of-the-box cycles come. Manufacturers will drop their cycles in here, and the user will drop his cycles in here. Now, when you boot up the machine, it's going to load these cycles into memory. So whenever we put something in here, to activate it, we do have to reboot the system. So we're going to do that in a second. But with that being said, what happens if the same cycle name existed in potentially all 3 folders? So this is kind of the hierarchy. When the system boots up, it's going to load all the standard cycles. Now, if a cycle has the same name and it's in manufacturer, that cycle name will override the standard cycles, and that's the one that becomes active in memory. If that same name file, like L6, let's say, was also sitting up in user, then user will overwrite manufacturer, which overrides standard cycles. So if you guys need to manipulate or change or modify any cycles, don't modify the source cycle. Just move it up into the next level up folder. So for me, I would say if you wanted to change a manufacturer cycle or a standard cycle, copy it into the user cycle, because that's the one on the highest level of our hierarchy. So if it sees that same file name sitting there, it's not going to delete these, but that's not what the system's using. The system's going to use this cycle. And then if you certainly mess something up, which is always possible, you could simply delete this cycle in the user cycle, reboot the system, and then it'll go back to using the original manufacturer or standard cycle, either way. Now in our case, there is not another safe position 2, so theoretically it could be in either of these 2 folders. You can't ever put anything in the standard cycles folder, because we rebuild this folder every time the system powers up. It keeps somebody from messing up our source cycles. So don't try to put anything down here too. You're going to lose it once you reboot. So you're going to use the user cycles. Now when I need to reboot the system, all else fails, hit the big disconnect on the back of the machine and cycle power. But you can also do what's called an NCK reset. So I'm just doing that with the reset PO button here. I just came back one menu. I came out of the system data area. I backed out, and that gave me access to the reset PO button. So if you're at all confused when you have to reset memory or you don't think something took, just cycle physical power. That's always going to be the best case scenario. But here, this is like a soft boot, right, or a warm boot. Okay, so we've got the file sitting in memory. So right now, if I was to go back to my program area and I went into a simple main program and I had a program that's calling SafePause2, we notice it doesn't exist anywhere here in NC memory because it's sitting in that other folder. However, if I go to run the system, and I'm going to put an op stop on because there's an op stop in that cycle, you see that it jumps into safe position 2. So I'm in here, I'm running that program right now. You even see it named right along here. Now, when you start to work with cycles where they're being called up from other cycles, you can kind of lose track of where you are pretty quickly. So we have a function called program levels. Button's right here is a vertical soft key. And this is what's going to kind of allow you to keep track of where you are in a program. Because you could be 3, 4, 5, 6 levels deep in a bunch of different calls. So if you're chasing a problem, well, step one is you got to figure out where the alarm or the problem's coming from. So hit program levels. Right now I see my safe position 2 is the program that I'm actively running. Once I come out of that one, see how it jumps back to the main program? I'm back in my main program. So I just put a couple labels in here so we can kind of keep track as we bounce back and forth. But what we can see here is now the system, because it didn't see that file name from anywhere else, will find it sitting in that user folder, run it, come on back. And then I can just kind of bounce in and out as I go. Okay, so that's step one, right? We had to have a basic cycle we're working from, and we want to get it into the memory. So now what can I start to do with that cycle? Well, step 2 really would be, what if I don't want to have to call it up by a name? What if I want to call it up by an M code? Well, that's creating custom M codes. So you can start to use any cycle or file that you create and actually associate it as an M code. So now I can interchange the file or an M code number, totally interchangeable, and either one will call up the same cycle. Just like that L6 routine, well, I call that with an M6. Well, how does the system know that the L6 file is associated with M6? So that's what we're going to go through right now, and that's the MDs you're seeing here. Now, before we get into the machine data you got to adjust, there are a couple rules. First and foremost, don't reuse any of our predefined M codes. So those are the ones you see here towards the top of the screen. M0, M1, M2, M30, M17. Those are off limits. Those are Siemens system M codes. I don't care who you are, you don't want to reuse any of those. But you also want to be careful for using any M codes under M100, so 99 or less, because even if it's not one of the predefined M codes, there are PLC components associated with those number M codes, and the OEM or the integrator may be using those M codes and you may not be aware of it. And then you could cause some havoc if you collided them. So from safety's sake, I would say build any of your M codes with a value of M100 or higher. Now, there are some other files that change how M codes are associated. We're going to look at that in a second. That's that mmac.def file that we're referencing here. So to be safest, I would say if you're going to create a custom M code, I would reach out to the machine tool OEM and either through documentation or talking to them directly and find out what M codes are available. That would be the safest thing by far. But if not, you can do a little bit of exploration. If you stay above 100, you're not going to hurt anything in the PLC, but you could step on another M code. That's very possible. And then what we're going to do is we're going to go in and we're going to look at these two variables. So let's jump back to Sinutrain, and let's now create this custom M code. So go back to Menu Select and Setup, And what I want to do first is I want to look at that, that definition file that I mentioned. So back under the system data folder, I'm just going to close up a few of these other folders. Right below cycles, there's a definitions file. And in definitions, if you see a definition file called MMAC, and there can be a bunch associated with this as different names, so be careful here. So it gets pretty dicey on some of the more advanced machines. But as a basic, MMAC allows me to redefine how M codes work. So if you look at this basic example, here we're saying I want to create an M13, and M13 will actually remap M3 and M8. So whenever I push an M13, it's actually going to do M3 and M8. This is a method of creating custom M codes. So if I built an M code that was called M13, I could start colliding with this. And you'll start to see, if you start to dig into some of these files, and these files can reference other files, it gets pretty deep pretty quick, how all these M codes can be built. So again, step one, especially if you're a user or a dealer, I would say reference the OEM, ask them what are available, tell them what you're doing. They should have a pretty detailed list of all the M codes they're currently using. Okay, but for us, how do I take SafePOS2 and associate it to an M code number? Well, it's as simple as going into the machine parameters. So go to machine data, you want to go to general MD, and you want to do a search for MD 10715. So when I look down in 10715, there's a bunch of what we call indexes, right? So a lot of times we'll have a machine parameter, but there's actually going to be a bunch of parameters associated in that same series of parameters. So 10715 has index 0, 1 through 3, and if I start to look down, we see it goes all the way down to index 29. So what that means is there's really 30 different M codes I can create. And what happens here is this is where I stipulate the M code number that's going to be referenced. So in my case, I'm making M code M100. So come into 715, go to an index that's open. So whenever I see one that's got a -1 value, it means it's not being used. In my case, I drop the value of 100 in here. And now you want to go to the next parameter set, which is 10716. So it's just the next series down. And if you scroll down, you notice index 0 is L6. So that's how your M6 is working. M6 is referencing L6. It's getting that subroutine. For our case, we're using index 1. So it's going to say, hey, index 1 has M100 in it. Well, what's in 10716? This is where I just throw the file name. No extensions, underscore SafePOS2. And now, whenever we create or issue an M100 in a part program or in MDI or in TSM, it'll look to that file and do whatever's sitting in that file. Now, these are power-up parameters, so if you change them, you got to reboot. Now, you notice I didn't bother changing them. I left them in the system to save a little bit of time. But in the real world, if you plug these numbers in, always be observant on what it says to the right. This is what's telling you what it takes to get that parameter to become active. PO always means power up. So the basic reset PO would be okay, or again, all else fails, just hard reboot the machine. So back in our program example, we were calling up that routine with SafePOS, but now I can replace it with M100, and I'm one of those guys that gets anal enough where everything's got to be caps. Doesn't matter though in our world, it could be lowercase. Now when I run the routine, reset, we'll start from the beginning. I get down to my safe position. I entered it, right? You see I'm in it from the M100. So we're now creating custom M codes. So it's, believe it or not, it's actually that simple. And I can bounce now in or out based on the safe position call or the M code. They can be used interchangeably. And that's really the start in creating custom M codes. Now, certainly some M codes have a lot more capability associated with them. Maybe you want I/O to be triggering, and that's probably where you're going to have to get into the PLC. But just basic functionality like this, it's really that simple. It's just associate a routine and whatever I want to be in that routine, and that's what that M code's going to do. Okay, so that's really kind of step 2, right? We built a basic cycle, put it into memory, and now we're calling it up with an M code. So how do I go from there? Okay. Well, this is where I got to start to be careful, right? So let's say, for argument's sake, I go jump into my sub, my M100 sub, this safe position 2, and I wanted to change some kind of G-code state. So in this example, we're just canceling our active work coordinate, whatever the part program was calling up, by issuing a G500. The problem is, when I jump back into the main program, well, it doesn't know to switch it back to whatever the original work coordinate was. So I've just now lost the active work coordinate. And that's a problem, right? I mean, the part program was written expecting G54. Typically, I only tell it in the first couple lines of the program. So now all of a sudden I have to have reissuing G54 or whatever my active work coordinate is every time I call up my safe position. So you want to be careful here. So if I think about it from a logic perspective, yeah, we could figure out what work coordinate was active, save it to a local variable, reinstate it, and that was kind of how we did it in the original example of this, this cycle back when we first did it in the previous webinar. But now that I'm using the cycles folder, I can get into some functionality that gives me a lot more tools in my toolbox. And one of the first things I can do once a file exists in the user folder is I can create a PROC statement or a procedure statement. And the PROC statement's in the first line of that program. And what it's going to do is this is the start of actually building a cycle. Now, eventually we're going to use this to actually push data back and forth. But in the beginning, once I've created the PROC statement, I have some additional commands that get really handy. And one of the first ones that's really helpful when you start to work with this type of routines is the save command that you're looking at here. So just by literally typing the word save on the PROC line, like I see right here where the syntax is PROC, and I call up my subroutine, and then I give that word save. What that does is it's going to save back in like a buffer whatever the active modal G-code functions were. So if I issued a G91, let's say, in the subroutine because I want to incrementally move, I don't have to then switch the system back to G90. That'll happen for me automatically. And what's nice about this is, I never have to make any assumptions, right? I would never want to assume that I'm always switching the system back to G90 when I get done with my subroutine, because how do I know it was really in G90 in the first place? Right? So you have to start to add all this logic. Well, this handles all that for you. It's just saying, hey, whatever was there as you entered into this cycle, put it back when you're done. So in our little routine, this can help take care of that G500, G54. Now, there are some other commands you can utilize here. There's actually a bunch. I'm just highlighting some of the more common ones. So we can do display off or single block off. What display off does is that is the one that will hide you from being able to see where you are in the cycle. So that's real common once builders and OEMs start to create custom cycles. They don't necessarily want you to see every move that's in the cycle, so they use the display off command. Single block off suppresses the single block command. So if I don't want to allow somebody from single blocking every single event or line, then I can suppress that. Now, I do see some questions coming in. Please keep typing them. I'm not going to read and go through all the questions until we get to the end, so don't feel like I'm ignoring you guys. We're going to kind of let these questions build up. Maybe I'll answer them, maybe I won't, based on the content, but we will review all questions when we get to the end, just to kind of keep things flowing. Okay, I just want to explain that because you guys have been really good typing in questions, so I just want you to keep them coming, and we'll review them in the end. Okay, so these are a couple additional commands I can use with the PROC statement. So what we're going to do is we're now going to kind of change the behavior a little bit of this cycle that we just created. We're going to create a PROC statement, and then you're going to get to see how I can now switch the work coordinate system, for example, in the middle of the cycle, and it'll automatically come back in. So that's what we're going to do right now. We're going to add our PROC statement to the cycle, and we're going to add our work coordinate line. So we jump back over. In this case, I want to start editing that cycle. So again, I'm going to find the cycle in the setup area. I have to go to system data, and then I have to just edit it here. So this is fully editable. You're going to open it the same way you normally would. I can use the blue arrow to the right to open it up. I can close it with either the close button, or I can arrow over if I'm on the first line. I can use the open vertical soft key. So any of the methods that you're used to using in the normal editor section under Program Manager, they work here as well. So there's nothing unique here. It's just that it's sitting somewhere else. Okay. So we'll open it up. We're going to edit it. And the first thing we want to do is we're going to move our def statements down. Now, traditionally, if you've used def statements, you know that they should always be the first line before anything else. But when it comes to a PROC statement, PROC has to be the first line above all else. So as you start to use the PROC statement, put that right up top. Now, you do have to reference the name of the file. So we want to give that. No extension required. Just type in the name of the file without extension. And this is where I can use the save command, right? So just type save. This is where I could do space display off, or the suppression of the single block. Right? They all would just go right on this line, one after another. Just put a space in between them. Now, just to show you the functionality, here I'm going to push in a G500. So I'm canceling whatever active work coordinate is has been loaded, but the save command, that's going to help me on the other way out. Okay, so we've plugged it in. Now, whenever you start to create PROC lines, or you've changed PROC lines, you do have to make sure you cycle power. Other than that, I'll be able to edit the cycle all I want without having to cycle power. But if you do anything in the PROC statement, make sure you remember to reset the system. That's going to reload the cycle. So if we add variables, eventually we'll be putting variables and stuff in there. Just remember to reboot. Okay. So now I come in, and just to show you real quick, my system's sitting in G54, right? So we're going to run this. I'm going to turn on my op stop, because I have an op stop in the middle of that cycle, that routine, right? So she jumps into the safe position. I'm here, and we see it canceled my work coordinate. Now, as I hit cycle start, I come back out of it. See how it reinstated? So that's all a behavior of the save command. I didn't turn G54 back on. So if I didn't have the save, this would not have happened. So that's where you can start to see how that simplifies, if you can imagine all the logic we would have to add, just like we did originally when we were checking other types of states. Now, if you refer to the page I just showed you, or the slide I just showed you, it is specific to G-code commands. So when you are using the save, we did some things with like the active tool number, the state of the spindle, which is an M code. This stuff would still have to be here, because the save command will hold any modal G codes, but not other M codes like M codes or D codes, stuff like that. Okay. So let us continue on. We're starting to add some complexity. So step 2, well, now I'm probably going to want to give myself a little bit more brains to the routine. Because one of the first problems you usually run into when you start to build these kinds of cycles is, I just wrote a cycle with hard-coded dimensional data in it. Well, that's going to be dependent on a specific unit of measure. What if you're trying to run the machine in the other? So, right, I'm putting inch values in, but what if the system's going to run a metric, or vice versa? So here's where we can start to get into logical conditional statements. So there's a couple different ways I could check to see if the system is in either inch or metric. First, I could read a machine data. So you may or may not realize, but MD10240 is where the machine data is saved for what unit of measure the system's currently in. So we can go and we can take a look at this MD and see what it's in. But there's also another way to do it. I can also read the G-code group. Now, there's problems when you get into using these types of routines. So if I just use the system variable, well, that's looking at whatever the state of the machine in jog is in. But what happens if the machine's sitting in inch mode, but I issue a G71 or a G710, right? That's switching the unit of measure in the part program. This variable is still going to stay at inch, even though the part program switched to metric, because the actual system hasn't switched. So that's where you can get in a little trouble, right? If a guy is changing the unit of measure in his part program quite commonly back and forth, then your conditional logic may come back with the wrong results. So here, this is just a little routine where I was validating and coming up with some conditional statements for either or I could use the G-code group. So this is the one we're going to use, but we're going to show you that a little bit. So in our case here, I'm going to use the G-code group to determine what unit of measure the system's currently sitting in. And then we're going to add in some conditional logic to say, hey, if my unit of measure is either a value of 2 or a value of 4, and that's what the double equals means. Equals actually says if the variable equals that, or if the variable I've built equals this, then you must be in metric. If it's other than that, then I want to be in inch. And that's what's going to determine where I go within the routine, right? Think of this as you start to look at logic statements. Think of it kind of like water flowing down a river, right? And then it's going to hit a divide. Which way am I going? Those are your if-then statement logics, right? If this condition's true, go to this, and the underscore metric, that's just a label, right? All I did was create a simple label and pointing the system to go there. Or, which is my else statement, go there. And that's allowing me to jump over sections of routines. And then at the end, so I don't run this section of code, I want to do a final jump to a new label and then continue on. So there's a lot of little jumps going on when you get into this conditional logic. So let's start to put this in and show you kind of how this works, because now we're starting to get into a little more complexity, right? So what I did, just to save us time, is I did add in some routines that I have in the background. We can kind of copy and paste, and we can build them up from there. Okay, so we are going to actually, yeah, we're still in save +2. Okay, so now at this point, what I want to do is I want to add in those logics or conditional states, right? So when I'm inside the part program, even when I'm over in the user folder, I can open up further programs. So you can still grab material from one area to the other. So in my case, I have a subfolder here called Logic in Action. And this is where we can start to plug in some of this logic, right? So our initial PROC statement stays the same, but now I want to create a new variable. So I'm defining an integer, and what I'm doing is I'm setting that integer equal to this program group. Okay, so here, let's give myself a little bit of room and drop it in. Now, the program group. Well, how do I know what program group to reference? That would kind of be step one. Well, this is pretty cool. So let me close out of here for a second, and we're going to go to the auto screen. Now, if you've ever used the all G-code functions, which a lot of you I'm sure have, you notice that there's numbers to the left of all these commands. That's the G-code group. So in my case, I come down and I say, okay, well, where is G70, 71, 700, 710? Where does that exist? G-code group 13. So with G-code group 13, if I query or check the state of G-code group 13, it's going to pass me back a number, a value. Now, if you don't know what these values are, you can dig through our documentation and we list them all, or you can just kind of test it, right? So that would be an easy way to kind of check the state of that G-code group. But the syntax in the command is what I'm using right in here. So it's a matter of $P underscore GG, and then inside of brackets, that number. And that variable right there is what holds the state of that G-code group, right? So if I took this G-code group, and maybe we went just over to MDI real quick, and I'm just going to give myself a little bit of room, because this is how I check a lot of this stuff. And it's important to kind of look at this, right? So what if I want to find out what the state of this G-code group is right now? Well, I can set it an R variable equal to it. And now let me just put in the R variables some giant numbers, some number obviously not that, right? Now I hit cycle start. It just read the variable. I go back and I see it's sitting at a value of 3. So I could start to play around with this little program. Oops, Let me stay in MDI, and I could use my G70. Now make sure you put a program stop here, because the M30 will revert it back to whatever the system's in. And I don't care what the system's in. I want to know what the part program's in at that given time. Right? So we're at the program stop. I have it at M30. I go back. I see, oh, I'm at a value of 1. Now watch, I hit reset. It's going to make a liar out of me. I think I was sitting at 1 maybe. Let's go to another one. Oh, no, I didn't. I didn't hit the, they're still hung there. So there's my G71, my 70, my 700, which is still inch mode, but it's slightly different functionality for those of us who know the difference between 70 and 71. See how it's passing a value of 3. So if I do the same thing, 71, 710, you'll see it pass a value of 2. So this is a quick way for you to start to figure out what the state is of a G-code group, and you can start to use it in your little routines. So for me, back in this part program, we are stating that, hey, we're going to check the units of the G-code group. I'm going to open up the further program. Let's get back into our logic and action program. Okay. So now, once I validate this, right, now I'm going to add some new code. So here, this is my conditional, right? So I have to check. I'm going to do all of this. So let me just mark this real quick. All right, so basically I'm grabbing everything from here. So what I'm doing here is I'm actually saying, and I'm going to drop this after my spindle states. Yep, so over here, anywhere after this, because all my spindle states, all that stuff's still valid. All right, so we're going to put all these conditions in. But what I am going to get rid of is I'm going to get rid of my previous super commands. Because what I'm doing is I'm saying, hey, go check the state of the control, whatever unit I'm in, and then if you're in metric, jump down to the section in metric, and now modify my position data, right? We plugged in earlier with a variable. Well, multiply by 25.4, because I know internally in my cycle, I made those values inch values. So if I just times them by 25.4, now it converts them to metric. If I'm an inch, jump over, and I'm an inch. So now, just by adding that basic logic routine, and I have a little message command here that I plugged in just for our demonstrational state. But now, if I close out everything, and we go to our program, go to main, let's say we're at 700 here, and then we're going to go to 710, right? We're going to jump into the same routine using 2 different methods. That's all good. But if you watch, come on. Now she's going to slow down on me. Okay. We cycle start. We go into the first routine. Well, it knew that I was an inch, so it came down and it would have executed that section of the inch program. I come out after I get past my optional stop, right? I'm out in my main program. Now we come down. We're going to do our dwell. Now it jumps in and it said, oh, you have a G710 prior to this. Well, you must be in metric. And now it's going to do the metric equivalent. Now, although this display you won't necessarily see here change, if you looked at the calculated values, you'll see that it's calculating a value and going to the right location. And then we come back out. And she's back with the active commands, and everything's good. So we can start to really change the behavior of a cycle, just adding a little bit of these kind of if and then statements, right? And that's how we can kind of start to steer and change the behavior of this cycle. Okay. So where can I go next? Well, next step is, why should I have to add all that functionality to my cycle? Maybe I want to let the user drive where this retract position is. So that's where we can add in the ability inside of the PROC command to push variables from what we call a common delaminated string. So if you've ever written a cycle in Siemens, you know that the cycle, even if you use the mask, creates a cycle name, and then inside of parentheses, it's got a bunch of variables. And that's what allows me to push data back and forth. So that's what we're like rating. We're not doing anything different than a drilling cycle or a tapping cycle or any of our cycles. This is how it all gets built. So you use the PROC command, but we can start to add variables inside of the PROC statement. And now I don't have to use all of that logic that we had before. So if we look at it here, on the left is the main program. So it's going to change a little bit because now I'm going to use the cycle name, and I'm not going to use the M code anymore because I want to push in a common elimination trim. So I'm going to take that cycle, and I'm actually going to rename it retract, and now we're going to add in some functionality to it. So what we're going to do is in the PROC statement, I'm now going to call out some variables, and those variables would be the same as doing the defs below. But when I'm going to push them from another program, I need to define them inside of this comma delimited string, because that's also what defines the placement of the variables. So my X home position, that's going to be variable 1. My Y home position is variable 2. My Z home position is going to be variable 3. So that's why if you look at this string, this PROC statement, 1, 2, 3, X, Y, Z, I just got to match that in my part program. But this is the behavior. Now you're going to look and you see, look how much simpler, the cycle is. Well, I don't need all this fancy jumps and all this crazy logic back and forth because I don't need to validate it with Instrumetric. I'm leaving it up to the user to put in the appropriate value. So it starts to make your cycles actually a little bit simpler. So this is what we're going to do next. We're going to build a retract cycle. So let's come on in. And let's take a look. Now, I think, do I have one in here done? I do not. Okay. So let's build it because I think it's important for you guys to see this. So here I'm going to copy and paste, but now I'm going to change the name, and the name of the file is going to be retract. Okay. So it's still an SPF, right? That's going to be the same. Inside the cycle, I need to change this to retract. Okay. And then we're going to add our comma delimited string. So let us go. I'm pretty sure I gave myself this program. Where are we? Pushing variables. Yep. Okay. So this is going to be the new string, right? So I changed the name of the file because the name of the file is now changed. And then in my comma delimited string, I'm really moving up the variable statements, the definition statements that I built below, and I'm putting them inside this string. And I don't need the def commands. So now all of these variables, not needed anymore. In fact, they can't be there, right? Because they've already been defined inside of this cycle. I got the save. I'm not going to worry about the display off. There's a semicolon in front of it anyway. That's a good way to suppress these commands at the end. If you have display on or have the single block suppression here. If you're debugging, you may not want it there. So just put a semicolon in front of it. That's why I always have save first, because that's one I would never want to suppress. And then I'll have the rest of them. Okay. I'm still going to use some local variables. That's okay. But my unit stuff, I don't need this stuff anymore. It doesn't mean anything to me. All right. So all that stuff can go away. I don't need to cancel my coordinate system. I can, right here, really just take this, copy that, drop it here. Yep. All right. So we want to keep our safe position. All of this stuff, I mean, really, almost all this logic goes away. So just to keep it a little cleaner, I'm just going to grab all this stuff. Let's delete all of it. Make it a little bit faster here. All right. Because now a lot of that stuff that I had before, it's not required anymore, right? I don't need all those fancy unit of measure checks and all that stuff. So my cycle, I still want to grab the D number, the spindle state, and I'm going to put the ops. So functionality, it's all going to be the same. But everything else, I'm now relying on the values pushed in by the user. Okay, so I do have to make sure, remember, I created a new cycle in users, and I've also manipulated the PROC statement on top of that. So let's do a reset power. There she goes. Okay, she's back up. So now I can start using that cycle, right? So I got this retrack cycle. So if I go over, I have a main program number 2. So now we're going to come in and we're going to test the cycle. We're going to push a couple values into it, right? So I'm going to tell the machine to go to some locations based on this retrack cycle. Now, a lot of times when I'm first building mine, what I like to do, it makes it a little easier, is I'll come in and I'll grab this piece of the cycle. And then in my main program, when I'm going to go test, I'll just kind of drop that in. This is my reminder, and I can put a semicolon too, but this will be my reminder of where each variable exists, right? In case I forget. And as you get more elaborate on the number of variables, you can lose track. So you could either put a semicolon in front of this and keep that as a reminder here, or you can just replace the numbers. But that's really what the cycle line looks like. Okay. So here, we don't need that. I was adding we're going to add some additional functionality later. So if we run this new program, now you see we jumped into the retrack cycle, and then we come back out. It resumes, continues on, jumps in. So it's doing all the same behavior, but now it's pushing the machine to those values. Now keep in mind, these numbers are based on the machine coordinate system, right? So in this case, it's not necessarily going to be the displayed position, right? That doesn't look like the number I said. Well, look at your actual machine values. Oops, come on. And this is where it'll match. Now, I have some inch metric things going on, which is some conversions too. So if we were to look back at this program, you can see I'm in 710. Down here, I'm actually in 700. So certainly we could look at this in a lot more detail. The system's now going to change these values based on that unit of measure, right? So it's going to display a little different because it's always an inch right now. I haven't changed the actual jog screen, just what my part program is doing. Okay, so this is kind of how it all starts to work. Now we're pushing values, all with that PROC command, back and forth. So here you can really kind of stretch your legs, and we can really start to add in some pretty cool functionality. So here we're jumping back and forth, but what if I want to then validate a number? So once I allow a user to interact with this cycle or routine, I'm probably going to want to check to see if what he gave me is correct, right? So what we're doing here now is I'm not adding any more variables, but I'm saying, hey, maybe on this machine or these series of machines, I know that all machine travel is a negative direction, right? It's pretty common in Z that if I move the Z in a full plus direction, where she stops is machine reference 0, right? So that means prior to setting a work coordinate, all travel in Z is negative. Well, since I know this value is based on the machine coordinate system, then it stands to reason that I want to make sure that I don't plug a positive number in, at least for Z. So in this case, I'm saying if my Z home variable is a value greater than 0, I want you to jump to a label called error. And my error command now exists below an RET statement. So I can have return or M17 in multiple places in my routine. Because remember, you're jumping around. It's going to yell at me if I put some kind of cycle below my M17 and there's no end of program there. But this return is what would bounce me back. So normally if it came down and this condition was not true, then it would just finish the routine, hit RET, and jump back. But if I see Z home is greater than 0, I'm going to jump over here. Now to cancel out the logic of this routine, I can say else and nothing and then my end if. And that means just, hey, continue moving forward. Yeah, it's possible you could get away with not putting these pieces of the conditional statement in. I like to put them just because it keeps things a little more consistent, right? I have an if or an else, and then I always end my logic statement with an end if. I'm ending this logic statement is what my end if comes in. So this is our next step. This is how we can start to add some error tracking into it, right? So let's plug that in, and then we can start to see how that would work. So in the routine, we're going to open up our other program, save ourselves a little bit of time. And I called it error checking. So now this stuff's all staying the same, right? But I have a conditional. So we're going to copy that conditional in. And I want to certainly put the conditional in prior to moving the machine, right? Because I need to check it before I move it. So be careful where you place this stuff, right? So this is saying, hey, if zhome is greater than 0, go to error 1. So now I need a label, and I'm going to put the label down here below my M17. Now I am going to change this to an RET command. You could actually leave it as an M17. RET is actually better to use when you're in some of these cycles because it returns quicker than an M17. M17 would basically make the whole system fully complete all its functionality before it goes back, like a continuous path type of function. RET just says, hey, you can jump back, and its return is a lot quicker. When you get to a lot of heavy logic, it gets back a little bit faster. So just a little different way of doing it. Okay, so below the RET, this is where I need to also add my error command. So I have my RET. Now we just give it our error command and our M17. And I would need to have the M17 below here. Oops. There we go. I don't need this line. That was just for my own reference. Okay, so it's coming down. It checks. If this condition's true, jump down here. Else, if it's not, just continue on. And once I hit RET, it's going to return. Now, it's important when you're putting in these little condition checks, and we talked about this a little bit in the last seminar, to keep it from moving forward. So you can use these directional go backs, and I can trap somebody in here. So the only way for them to get out of this little routine is to actually hit reset and not allow them to go any further. If you overskip this jumping back to error 1, this little loop I created, then what will happen is they could cycle start right beyond this error, and then it would still go back to that program. So be careful when you add error trapping. Now, what I would say is always add a program stop in it as well, because if you don't add a program stop, the system will keep on executing basically infinitely, and then it'll give you resource alarms. So I would want to make sure I tell it to display the message, put it in a stop state, but if a guy re-hits cycle start, just display the message again and keep looping it until he hits reset. Okay. So I didn't change anything in the PROC, so I don't need to reboot. So now I can come into my program, and my first one's okay, but I'm going to make my second one no good. All right, and I'm going to reduce this dwell. It'll be a lot quicker. Okay, so we go to execute. We run, safe position. I'm going to let it bounce back. It's back in the main program. You see we're back to the main program. Now we come into the next retract, and here, boom. The Z value must be 0 or a negative value, or anything that I had in the message. And this is where I've caught them now. So I'm in the retract. If I keep hitting cycle start, machine's not going to go anywhere because all it's doing is it's saying, oh, go back, and I'm using the directional command in the go to this error message, and I just put an infinite loop. So you now have to reset to clear the message. If you don't do that, if you hit cycle start, it would go back to the program and keep running anyway. And we know that value is no good. So we can start adding conditional checks and traps to keep somebody from plugging in wrong numbers now, just by kind of bouncing around with go-to statements and catching a loop. Now, I wouldn't put it into that indefinite loop and not give the guy a message, because that'll just drive you crazy, right? You're not going to know what's going on. So just keep that in mind as you start to build some of this stuff, that you want to give as much interface to the user as possible. And you see any message command gets displayed right up top. You know, we've talked about these message commands in the past, but it's just MSG, parentheses, and whatever's inside of quotes will display on the screen. Okay, so let's add a little bit more functionality. We got a little bit more time here, and I'm not done talking. So what if I want to also add a condition where maybe I want to allow this cycle to clear the spindle if there's a tool in it, but not always. I'll leave it up to the user. So I'm going to create an integer now, right? I had a bunch of real variables. Those are true whole numbers. Now I'm going to create an integer, which would have to be a number, it's not a non-decimal number would be an integer, right? So it's a full number. I'm going to create an integer called toolClear. And toolClear is going to say, hey, if toolClear equals 0, I want you to do a T0 M6. Else, I want you to just continue on. So here I don't need a lot of jumps. All I'm really basically doing is saying, hey, if I see a 0 value in here, then I want you to clear the spindle. If I see a number, anything other than 0, just keep on going with the program. So I've just now added a little bit of functionality to the routine where I can let the system do a spindle clear. So maybe if I'm using it at the end of my cycle and I want it to clear the spindle, boom, I put the 0 in. If I want to use it otherwise than that, then I can put a value other than 0 and it'll continue on. So to execute or add that to our functionality, we're going to open up the cycle. Now in this case, we're adding another variable, right? So when I'm adding another variable, I got to remember to reboot the system. So we're calling this adding tool change. So we're adding the integer tool clear, right? So I want to grab that comma. You got to make sure there's commas between these. All right. So I've added in the integer, so I'm going to have to reboot the system. And then I want to add in the section of code that's going to handle the tool clear, which in my case, I'm just doing a simple T0 M6. Now, obviously, the machine has to support tool 0. All right, so we're putting that right here. We're doing it after our end error check, because I certainly would want to probably clear the spindle before I send her to that safety location. This could be in either spot. It really doesn't matter, right? It's the intention of the guy building the routine, i.e. now me. Okay, so to get this to happen now, we're going to reboot the system. So I'll just do a reset PO. You notice when I do a reset PO in SINUTrain, I lose my enables. So once it's back, I just have to click my 2 enables, and now I can start running again. Now in the system, if I added a variable and I don't plug it in over here, well then it's still going to run, right? So it's possible that you can add variables, and you see how I have a tool change, and that's not clearing the tool on this one. So my first routine I did not have, actually I still have an error in there, right? I left the error chop. Let's give it our negative. All right, so in this case, this machine previously had a tool 0 before the routine. So it's just negating that section of the code because I haven't told it anything in the cycle to do anything with. So when I have segments like that, so here we see the next tool was in it. Oh, we're already out. It cleared the tool back in. That's why I had that larger dwell. Let me put that in there so you can see it. Okay, so we run the routine. So she's at the safe position, comes back. Now I have demo tool in there. She comes out. Oh, actually, with this logic statement, it's clearing it because it is hitting it. It's assuming that value is 0. Okay, so now let's put in some numbers to make it work. Okay, so in this case, it should maintain the tool that's in the spindle. And we could even put a tool here. We'll do 2 tools. Control copy. All right. I'm doing this the long way. Okay. All right, so I got my drill in there. She comes through the retract command. Nothing happens, right? Doesn't do the clear because I got a value other than 1. And it pulls back, everything's happy. Now maybe I want to clear it at the end of my routine. I set a value of 0. Now as I run, maintains the first one. There's my demo tool. Now we jump in, you see where it handles my tool clear. All right. So we're adding some conditionals, we're adding a little more functionality. So you can get pretty elaborate with what you allow these cycles to do. Now, with that being said, I may want to add some trapping or error checking to validate. So in this case, I get a little bit more detailed, right? Here, I want to basically say, I only want to support a value of 0 or a value of 1 in that field. I don't want somebody to just be able to randomly put any number they want. So we're just going to add an extra check prior to running the tool 0 routine we just added. And that's saying, hey, equal means if tool clear is either 0 or 1, then you can move on and do whatever the routine says. In this case, if it's 0, do the T0 command. But if it's a value other than 0 or 1, then you want to go to your error jump. So this is going to be the next piece of logic we add into the system, right? And now I can start to trap it. But we want to be careful here. And I intentionally did this to kind of put us into a corner, right? I'm using a conditional assuming a value or 1, but my variable is an integer. So what happens if somebody puts a value of 0.5? Well, an integer is going to round up or down, right? Because it always has to be a whole number, not a real number. So because of that, I have a problem in this cycle. So this would be a case if I really wanted to get this cycle to work flawlessly without any chance of error, then I would change this variable to a real. For instructional sake, we can leave it at the integer, but track that, because you're going to start to want to check your routines and try to break them as you build them. So think of all the conditions that somebody might try. You may think, well, why would you ever want to put a value of 0.5? Well, people do it. They do it all the time, right? So you have to catch that. So in this case, this routine would fail if I put a value, a decimal value around it. Like even if I put a decimal value of 0.2, it would assume 0, right? Because of the rounding routine. Okay, so we'll add in this section into our routine, and now we can check to validate that condition. So we come back in. Now I'm not going to change the variable state, so I won't have to worry about clearing it. So I'm just going to open up our further program, and we're going to add in the pieces of the routine, and I called this validating user input. So for safety's sakes, just so I don't miss something, I'm just going to grab all this. Let me just do a quick mark, grab it all, copy, come over here, highlight all this, get rid of it. All right, paste. Oop. I lost my clear. Let's grab it again. Okay, I don't want the def or the proc statement, but I want everything else just for saving us a little bit of time. Okay, but all I did was put the exact logic that we're talking about, right? So here we have this jump command. So if I come in and it's not this, I'm going to now jump down to error 2 because I had an error 1 before. So now I have multiple errors, and I'm just going to keep dropping my errors down below this first RET or M17, whichever one I happen to have been using. I just keep building them up there between that and the final M17 of the routine. So now, if we close this out and we go to auto, everything should still run as normal, right? So everything's good. So what happens if I put a value of 10? I come in, run it, boop, tool change value, no good. Okay, so I just caught it. And again, remember what I mentioned with the real or integer scenario. Had I put a value of 0.5, didn't fail. Didn't do 0 because it rounded it to 1, when 1 tells it to keep the tool in the spindle. But that's where you got to really really understand the difference of these variable types. Something as simple as an integer or a real. You might just, I always want it to be an integer. Well, you sure that's what you really want? Or vice versa. So just be aware of it. I like to use it as a little example of how you can break your logic. But in this case right now, as long as we plug in a whole number and I use a value, even if I go negative, it would still fail. So there, valid's no good because it's just saying, hey, just 0 or 1. Those are the only two I'm going to accept. Anything else outside of that, I'm going to fail. And once I switch it to a real, then even decimals will fail. Certainly if I gave it a decimal that's going to round up to a value other than 0 or 1, that would still fail. It's just when I have those decimals that would round to a 0 or 1. Okay, so I know I'm going quick, but we're covering a lot. I just kind of wanted to give you a whole kind of scope of what you can start to do within these cycles, and just using these simple PROC statements and getting into a little bit of the logic. Generally speaking, when you first start to get into using logic statements, the protocol, sometimes you can change a little bit, but generally when I'm not getting the result that I expect, then I like to reference back to the manual like we talked about earlier, and I see how they built the logic, and I just try to mimic that. Because boy, you just change things slightly, like forgetting to put parentheses around these conditional statements, it'll break. You won't be able to use it. Sometimes if I forgot to put the else command or the end if statement, I might get weird responses. So if you're fighting with how things are reacting or working, just refer to those manuals. They're really good, and just follow the syntax, because the syntax can be a little fussy sometimes, because a lot of stuff's going on. But just try to give you guys a pretty well-rounded view of what you can start to do as you get into this type of programming, right? So we've been using messages to catch somebody, but what if I want to make something look a little bit more sinister, right? Beyond the obvious joke of, hey, I got a big red alarm across the screen. Things that I can do with these custom alarms, and if you look on the right side of the screen, based on the alarm number, I can make certain things happen. So like in this case, I was putting the guy into a little trap state with that go to back command. So he would have to reset. But if I use an alarm in the 65,000 series from 65,000 up to 65,499, that's going to automatically disable NC start. So I wouldn't even have to have that little logic in. Now, there's a bunch of different ways to get into alarms. Certainly, I would say if you're going to play around with these alarms, you want to just double check with the OEM to see what ones they've used. But probably the easiest and the safest thing that you guys can do is use the set alarm command. And if you follow this syntax, right, so set alarm parenthesis, the number I want, and generally speaking, as you start to create your own alarms, I would just use that given number for that type of alarm. But the number you want, and then inside of quotes, you can pass a basic message. Now, it's going to come up just to the left of this other message field, so you're always going to get that no text available. That comes in when you actually build custom alarms through our full-blown interface. Here, we're just writing to them. So this is a nice, quick, down and dirty way for me to start pushing into the alarms. Now, I can get pretty elaborate, right? So I can build in other versions of text in it. I mean, you can go pretty far with it. But as a simple, hey, I want to just push up an alarm that's going to inhibit the machine cycle start because this alarm has occurred, and I see a real alarm, not just a user message. This is a way to do it with this set alarm command. So for us, let me go back to SINUTrain. I came in and I actually plugged it in earlier. You didn't catch it because I'm so quick, but here you go. I had the alarm commented out. So we were using the message command. All right. Now, in this case, I'm going to get rid of the go to back, and we'll leave the M0. Garbage sec. So if that alarm's functioning properly, I should not be able to hit cycle start to go any further. So let's try it. So let's go in. We can close this routine. Let's break our program, i.e., let's put a value that we know is going to fail, so it jumps down into that alarm field. And there you see, now we're displaying something that looks a lot more noticeable by a user to say, hey, tool change, value no good. Unfortunately, yes, you're going to see this no text when you're doing them with the set alarm the way I'm showing you. But if I hit cycle start, program action controlled. So this is inhibiting me from moving on based on the state of that alarm. What's also cool with those alarms is they're going to store in your log. So if you want to be able to trap or capture the fact that guys have been putting in values incorrectly, the messages won't be saved anywhere, right? It's just a user message. You would see it here temporarily while the message is active, but once it's cleared, it's gone. If it's an alarm, it's going to write to the alarm list. So this is another reason why it might be nice if you have especially very specific errors that you want to be able to trap and capture, the alarm command will then propagate and then even save in the log and everything. So they're going to work like full-blown alarms, but I'm just setting them with really just that set alarm function. So just to look at that real quick again, see we have this set alarm, and then whatever number I want. So you refer back to that previous document that I showed, and that's going to be what really changes the condition type. So there was a bunch of different things that would get inhibited when we do this, right? So NC start, if I start to get into A subroutines, asynchronous routines, standstill monitoring, a whole bunch of things based on the number range. I'll be honest, generally for the stuff I do, I stay down within the 65,000 series right here, this first line. Because usually if I'm going to display this alarm, I just want it to get to the log, and I also want to inhibit somebody from being able to continue to cycle start past there. Okay, so we have the alarm. We see a push up. There we just uncommented that section of the program. So now the last thing I wanted to do is add a final section into the routine that allows a user to push up his own messages. So this is where we can start to use the string command. So originally we showed you using the basic string local in a part program, and I can push things up. Well, I can do the same thing inside of my PROC statement. So we can build strings. Now, when you do this, it's important to note that when you're typing in the value in the cycle, you do have to have quotes on either side. If you leave the quotes out, it's going to alarm out, it's going to not display properly. You need to put the quotes, because what you're doing, just like we did last time when we played around with strings, is you're setting the variable of the string. And whenever you set a variable of a string, it needs to be inside of quotes. So whether it's inside of a cycle or by itself, you always have to put the value that's being set into the string inside of quotes. But other than that, it's as simple as adding the string variable and then putting some kind of simple message command to say, hey, I want you to display whatever's in this MSG variable that we just built, and that's going to push the user message. So now a user can go in and plug in his own custom messages within the cycle we just built. So let's add that. That's the last little piece of this webinar that I wanted to add to the routine. It's kind of fun, though. It's nice when you build these cycles. You can really, as you're hopefully starting to see, you can certainly start to add in quite a lot of capability. And it's really not that difficult. I'm hoping you guys are seeing. I know I'm going quick in some cases, but there's not a lot here. You just get used to some of the structure and some of the basic rules, and you can build some pretty cool stuff pretty fast. I always kind of amaze myself sometimes when I get into this. All right, so I just added my string. Now I want to decide where my message is going to come out. So here we're displaying the message after we've moved to position. So let's go grab that. And if I look at, so we've just moved into position. So I'm going to plug it here. So no longer do I need this message line, because this is a static message line, right? This would not allow a user to be able to write to it. Now, one thing I'm probably going to want to do is before the end of my program, I'm going to want to add in a message clear, because maybe I only want to keep that message up when the guy has it in, op stop, as opposed to regular full program run, right? I don't want to keep displaying the message, but I also wouldn't want to necessarily leave the message up. So whenever you have a message and you want to clear it, it's just MSG, open close parenthesis. So I'm going to position this just before my return command. So here, as we come on down, it's going to push the user message, and then I'll see it, assuming I have an op stop on, and then I'm going to clear. So we'll have to do that. Now, I did add a new variable. So just make sure I remember to reset power. Very good. I heard you guys saying it. Okay. So we reboot. Now, in the program, I would need to add, I'll make that work again. Remember quotes and whatever I want to push. So we're going to run this. I want to make sure my op stop is on. Cycle start. And now I'm pushing in a message from my cycle through a string variable and displaying it up on my screen. And again, that was only displayed if I looked at the routine back up here with the message command, and I don't put the variable inside of quotes because I want it to actually push whatever's in the variable. If you put this inside of quotes, like we did before with the safety position, then it would actually display underscore message. Okay, so we went through a ton of stuff. I want to say, yep, we are at the end of certainly the content I wanted to go through, and it was a lot. I'm using all of my hour and a half that I told you guys I was put through, but we got a ton of questions. So let's go through here and see if we can move through. Okay. Just bear with me. I got to kind of read through these. Okay, so what do we got here? We got, is there a better way to convert from MD 11120, which is the extended scope 0 to 1, without having to rewrite all of the subroutine variable definitions? Some builders use 0, some use 1. Let me see what variable that is. I'll be honest with you, I don't remember them all off the top of my head. We got a lot of variables. Have you, if you've noticed? So this question is referring to 11120. So I believe, if memory serves me, user data of the main program level is also visible in the subprogram level. Yes. So this variable, the state of this variable will change whether or not we're allowed to pass variables from a main to a sub, and by default you're not. So that's what we call a program user defined variable. And whereas some builders use 0, which causes a problem if we want all our subroutines to run on all our machines. I'd like to avoid as possible. Do you have any recommendations? Well, what's the, but I guess I'm not fully following. Some builders use 0. Rewrite all the subroutine variable definitions. Well, I mean, you can just change this variable. So I guess I'm not totally understanding Matt's question. I mean, yes, by default, this is generally at a 0. So, and I always assume it's at a 0 myself. But it does mean that you have to redefine your variables when you jump to a sub from a main. If I switch it to a 1, they'll transfer over. But you should be able to change this on your system without really having any problems. As far as to my knowledge, it shouldn't affect anything from the builder side. But you know what, Matt? We can take this offline. Why don't you, if you're still on, reach out to me at some point and we can talk about this in a little more detail, because I don't know of any reason why you couldn't change this on your machines to a 1 if it came in a 0, and then you shouldn't have to recreate them. But we can certainly talk about that offline. Okay. Can you use the PROC save for the unit measurements, force a subroutine? Yes. So here, Dan is asking if we're using the save command, will it work for my unit of measure scenario? And it certainly does, right? Because it's all G-code commands, and G700, G710, G71, they're G-codes. So that would really save and put it back. But at that point, then, you would be switching the system to a specific unit of measure in the routine, which you can, just you want to be careful with that. You know, I don't like to necessarily switch the system. So if you remember in my logic, I said, if I'm in one, do one routine. If I'm in the other, do the other routine. This way, if somebody resets the program, in the subprogram in the middle of its executing, if you reset and kill that while you're in that state, well, guess what? It's staying in that state. So if you just switched a guy from inch to metric, and in the middle of the routine he hit reset, now the machine's sitting at metric, and he may not realize that. That could be bad. So just be careful with some of that stuff. And the save command is really powerful, but in turn, you could put somebody in a condition. You know, I don't like to switch too much if I can all avoid it. Like that little trick with the G500 thing, I would never personally really write a cycle like that because I wouldn't want to cancel somebody's offset. There's a much better ways to do that. Okay. Is there a reason to benefit to using the stop read command in this sub? So stop read, what that stop read does, so basically the question is, you know, using the STOPRE command. So stop read stops our look ahead. So you do get into some cases where, especially in these short routines, the look ahead may be displaying something different than you're expecting. Now, the routine may still function okay, but you may get some weird behavior. So if you think that it's the look ahead, like let's say for argument's sake, I'm telling it to cancel an offset, but I see the offset being displayed even though it's not being used, it might be the look ahead, you know, reissuing it. Then you can put a stop read command in, and all stop read would look like is, let me go into the routine, show you what I could do. You know, let's say for argument's sake, at the end, I don't want the system to be able to look any further than this point. I just really type in a COPRE. It's not going to do anything as far as programming is concerned, but what it does is it stops the system's look ahead. People lean on stop read a little too much, I think, at times. You see guys riddle them all over the place. There are plenty of times it's helpful, but I think more times than not, guys assume it's a look ahead problem, so they put stop reads everywhere. And that wasn't the problem. It was really a problem in their logic. And then they never take the stop reads out once they fix their logic. But it is handy when you have the look ahead looking too far down, especially in really short routines, because the look ahead might be actually looking outside of the routine again. Okay. Can you create help tests for user created alarms? Can you create a help test? I'm not quite sure I follow that one. Can you create help text for the user created alarms? That's a good question. I mean, it can. I've never gone that far as to what it would take to build in custom help for those routines. That's a good question. Maybe it's a good one for my next webinar. I can take a look to see what it would take. I think it gets pretty involved once you start to get that far. And the other thing you got to keep in mind is we're setting the alarm content just inside of a subroutine. It's not permanently there. So if that subroutine, you know, I could use that same alarm number in different subroutines and make the text different, and then that wouldn't really apply to help. I would say you're probably not going to go down the road of creating what this attendee is actually asking is, you know, when you're in a given alarm, right? I got an alarm displayed, and I want to know what the details of this alarm is. I can hit the help, and if there's information, it's going to show it. But if I have an alarm that has no information, it's going to tell me no help is available. So it's possible to create, you know, help segments, and some OEMs do it based on custom alarms. But this alarm would then have to be created permanently in the system for me to then associate help to that alarm. And you want to be careful creating permanent alarms because you can actually collide with other alarms that the OEM built. So I would say, from a user perspective, I would not go that deep because you could actually break alarms that are in this system. If you're an OEM or or an integrator, then absolutely you certainly can create custom help on a specific alarm. But you're not going to build the alarm the way I did it. You're going to actually build it permanently in the system. So that alarm, that 65,000 alarm, would only ever be associated to tool change value no good, for argument's sake. Okay. Tristan was asking when we're sending out an invite for the post-processor webinar. So generally speaking, I try to schedule the webinars about every 6 weeks because I don't want to hammer you guys. In addition to that, usually the first email blast goes out about 4 weeks prior to it. So in a couple weeks, you'll see the invite for the next webinar. Is there anything that can be done in the MMAC def that cannot be done in the UMAC def? That's a good question. Not to my knowledge. The first M or the first U, that really just stands for manufacturer or user. So as far as I know, they're fully interchangeable. I used MMAC for this example because generally that's what you're going to see in the system. And really, I was talking about it here more because I wanted to make sure people were aware that M codes could exist in the system, and you might not see them when you go into the user, into user MDs. So there's just another area to show you that be careful when you start to create custom M codes, because you could quickly collide in one that already exists in the system. So this is a really handy functionality, but you want to be careful when you get in here. So I would say more likely than not, you want to really have a good understanding of what's happening in the system as far as M code definitions before you start playing in this area. Okay, if you reset while in a PROC subroutine, will save on the PROC line, will the original G-code functions be reinstated? Okay, no. The easy way or answer to this is basically they're asking that if we're in the middle of the cycle that we just wrote and we hit the reset button, what happens? It's going to maintain the commands at that point in time. So that's where you want to be careful. And that's a lot of times why people may suppress single block, so somebody doesn't have a big chance to maybe hit the reset. You want to always be careful with that. But yeah, save won't push it back in. But any of the other logic commands would be a trick there too, right? Because if I'm resetting prior to my reset of the command, then they would be gone as well. Okay. Alan, pass a variable with a cycle call, the value of the variable, cycle be 0 or null. So if I think what Alan's referring to is if we leave the variable out, what's its condition logic going to be? I think it's 0, because if you remember before when I was playing around with this, I didn't have the tool value out of 0. I left it blank, and it treated it as if it was a 0. So what Alan's referring to here is, I'm in my main program and we built a cycle, but I neglected to put it in yet. I believe it gets treated as a 0. So you want to be careful with that. So certainly that could be a case why I might want to use maybe a number other than 0 if I'm expecting people to shortchange my cycles. In our standard cycles, we've anticipated that. So it's possible to run a cycle with less variables than we fully support from a legacy perspective. But there, we anticipated that. But yeah, you would have to anticipate that in your own routine if you think people are going to leave it blank. But I believe it's going to treat it as a 0. Okay, Andy is push an alarm where the operator would have the ability to clear the alarm and then continue on the program with just an NC start. Okay, so basically Andy's saying is, hey, can we throw up an alarm but still allow the guy to continue to advance? Well, that would really be more of a message, right? So in a case like that, if we looked back at our routine, and let's just go back into our routine. I was putting in this trap right here, right, to loop it. But if I just want to push in a warning and let them go beyond, well, then I just don't give it this go to back, and it'll still push up a message and then continue on. The physical alarm, like I was doing the set alarm command here, there is a way to do a set message command, and then that would also allow you to continue on. So yes, we do have ways. I could just do it in the way I build the structure of my logic to allow me to continue through and just push up a message. Really, that's kind of no different than when we pushed up the message up here, right? This message command, it'll just drive through it and continue on. Or you can, like I said, you can use, there are other set alarm functions that are more tilted to program messages. So if it's something that you're interested in, reach out to me and I can certainly give you more detail on it. What else do we have? There's you might want to make note about block search if they're setting something they would not want to be fulfilled. Not sure I totally follow Andy's point. You do have to be careful when the system is doing block searches, right? There's actually even more command structures we can put in that could basically check to see some conditional statements like a block search and then jump over a routine. So I do this pretty common when we do probing routines, right? And one of the areas with a probing routine that I may not want to validate is if I'm in machine simulation, because I could get an alarm because there's really no real trigger happening. So let me see if their L6 has it. But there is some tricks I can do. Nah, this is a pretty rudimentary one. But there are ways within the cycle to check the conditional statement of like a block search, or whether the system thinks it's in simulation mode. PRT mode is another method that a lot of times it's commonly checked. And then you can jump over everything. So basically what you usually would do, let me see if I can get my hands on one real quick if I have something in my memory. But what you could do is you could say, hey, you know, if in fact I think I'm in one of those states, then what I want you to do is I want you to totally jump over everything and just go right to the return command and come on out. So that's very commonly used. So if you run into that case where you know that the routine that you're running, and I don't see one at the top of my head. I mean, I got them in here, but yeah, I don't want to waste my time looking for it. But if it's something that you're running into where, you know, whether it be during simulation mode, it's running your routine, but you don't want it to, and maybe it's causing problems, yes, there's definitely a couple simple statement logics we can put in to validate that state and then jump on over it. This is from Matt. Besides the Siemens website, is there any user groups that folks currently logged could interact with each other and ask questions? As a viewer, we cannot see anyone who is logged on in the class. Help. So that's a good question. User forums, external user forums. I don't know of any specific one just for Siemens. You know, there's definitely forums out there that I interact with. That Practical Machinist is one of them. That it's a pretty decent resource. I will be honest. A lot of the forums, there's probably not a lot of Siemens content per se. I'm starting to do certainly more within YouTube. We have a YouTube channel called Mr. CNC that we do quite a bit with, and that's an area where doesn't necessarily let you interact directly with other users, but we're pushing out a lot more content at least. But as I think about it, if something else comes to mind, I'll certainly let you know. Okay, I think I got all the questions. Boy, this was a long one, and man, you guys held on right to the very end. I appreciate it. I want to thank everybody for joining us. I hope you guys got a lot out of the info. If you'd like any of this material, by all means, reach out to me. I'd be happy to push it out, and we're going to send the links out as well. But thank you, everybody, for joining us, and you guys have a great weekend. Take it easy.